Hello friends, welcome back to Technovision Education Services by Munasir. Our today topic in C language video tutorial series is Bitwise Operators. Means we will see each and every concept regarding Bitwise Operators, theory and practical both. This operator is most important topic for interview purpose also, as well as it is always two or three questions will be covered for aptitude test. So see all the videos carefully. If you found any difficulties, you may ask in comment box. So let's start. What is bitwise operators? The bitwise operators in C language are, there are total 6 bitwise operators. They are bitwise and, bitwise or, bitwise exclusive or we can say XOR, bitwise not, or it is also called bitwise ones complement operator, bitwise left shift, bitwise right shift. Since these operators works at bit level, that is zeros and one, therefore called bitwise operators, means it performing operations bit by bit, which is based on Boolean algebra. All it always works on int data type, means note says that bitwise operators are not applicable in case of float and double digit types. It always return output in integer type. So it always applicable for int type and also output will be produced in int type itself. Truth table. Truth table is important to understand the logic of bitwise operators. So bitwise and, bitwise or, bitwise XOR, bitwise complements. Out of 6 bitwise operators, there is only one, that is bitwise not, or we can say ones complement operator is unary bitwise operator because it required only one operand to operate. But for rest of bitwise operators, we always require two operands. Therefore, we have used here two operand values, means A and Y values. So, what the truth table say? For bitwise and, both values should be 1, otherwise rest of all values will be 0. So this is shortcut to remember how we can recognize what will be the output. For bitwise or operator, if both value means operand 1 and operand 2 both are zeros, then only it will produce 0. For rest of all operand, output will be 1. What about exclusive or we can say XOR operator? It will produce zeros for both, means if A and B both operands are same, if both are 0 then also it will produce 0, if both are 1 then also it will produce 0. If both operand values are different from each other, then only it will produce output 1. What about bitwise complement? It will invert the bit value, means we can say flip the bit value. If value is 0, then it will convert into the 1. If value is 1, then it will convert the value into the zeros. So that's why it is also called bitwise complement operator or ones complement operator. How they works? What are the basic requirements? Let's see. Bitwise and, both the operand value should have Boolean value 1 for the result to be 1. For bitwise or, at least one operand should be Boolean value 1 for the result to be 1. For exclusive or we can say XOR, either first operand should have Boolean value 1 or the second operand should have Boolean value 1. Both cannot have the Boolean value 1 or 0 simultaneously. Means for different operand, means for operand 1 and operand 2 both must have different value, then only it will produce 1. If both operand has same value, then it will produce 0. What about ones complement? It is applicable on only one operand at a time, either at A or at B. So therefore it is also called bitwise unary operator. The left shift and right shift operators are responsible for shifting for binaries values by some specific number of places. Bitwise left shift. It specifies the value of the left operand to be shifted to the left by the number of bits specified by its right operand. Similarly, how right shift bitwise operator will work? It specifies the value of left operand to be shifted right by the number of bits specified by its right operand. We will see each and every concept through theoretical and practical. Just we are discussing the basic things. First of all, how to write binary number for any decimal numbers we should know. If we have proper idea, then only we are able to understand what is the logic behind this. Suppose we have put here the value 1, 2, 4, 8, 16, 32, 64 and 128. So how we can write the binary for positive number? Let's see. Suppose we are trying to write binary numbers for decimal number 1. So here 1 is involved for the writing the number decimal number 1. Rest of numbers are not involved. Therefore, we have put here the value zeros. So for binary 1, we can write 0, 0, 1. Similarly, for 2, we can write only 2 number is involved. Rest of numbers are not involved for writing the binaries. So we have put their values zeros where 2 is involved. Therefore, we have used here 1. In this way, we can write the binary for all the numbers. For suppose 3, when we add 2 plus 1, it becomes 3. So it will 1 and 1, rest bit will be 0. Similarly, for 4, only 4 is involved, rest of numbers are not involved. Therefore, we have write here 1, 0, 0. Similarly, for writing the binary of decimal digit or decimal number 5, 4 and 1s are involved, 2 is not involved. Therefore, for 2 value, we have put here 0. Similarly, we can write the binary for any numbers. If you found any difficulties, you may ask in comment box. How to write binary for negative number? Let's see. Suppose we want to write binary for -1 to -9. How we can write? So for binary 0, every bit is zeros. So for -1, all bits value will be 1, 1, 1, 1. Means it depends upon the compiler, which compiler we are using. If it is 16 bits, then it required 2 bytes of memory space. If it is 32 bits, means it required 32 bits of memory space to store the value. But output will be same, not difference will be found. Suppose we are trying to write -1 bitwise binary operator, then 1, 1, 1 will be the equal to the -1. Similarly for 2, 1, 1, 1, 0. How we can calculate whether it is correct or not? So in case of writing the binary value, leftmost value is considered as MSB, most significant value, or we can say most significant bits, and rightmost value is called LSB, least significant bits or least significant value we can say. So if leftmost value is 1, then it always represents negative number. But if leftmost bit is 0, it always represents positive number. That is the way of identifying whether number will be positive or negative. It doesn't matter how many bits we are using. Suppose we have considered here 8 bits. You can also consider 16 bits, 32 bits. Output will be not different. So we have considered here for 8 bits how it will become -1. Let's see. Here for place value of 8 will be -8 because here LSB is 1, which indicate it is minus number, negative number we can say. -8, then 4 plus 2 plus 1 means it will be 7. When we add both of numbers means -8 plus 7, it will become -1. Similarly for -2, suppose we are taking here -8, then we are performing additions with 4 and 2 means 6. -8 plus 6, it will becomes -2. Similarly for -3, how we can calculate? -8 plus 4 plus 1 means when we use -8 plus 5, we will get -3. In this way you can calculate binary for any negative decimal numbers. Still, if you have any doubts or query, let me know in comment section.